In this video, we'll be talking about common saccharides. For this worksheet, we have to determine the type of glycosidic linkage and if the sugar is a reducing or non-reducing sugar. For the first sugar, we have two glucose molecules linked together. For the left glucose molecule, this will be carbon 1. For the right molecule, this will be carbon 4. If we look from the left molecule, our CH2OH group is up. And if we look here, our bond going to this oxygen is down. So this means this will be an alpha linkage. And it is between carbons 1 and carbons 4. To determine if the sugar is reducing or non-reducing, we have to look for hemiacetals and hemiketals. If you recall, a hemiacetal is going to have this general formula, and a hemiketal will have this formula. So for this sugar here, we can see that we have carbon, oxygen, carbon, oxygen with a hydrogen. This means that this is a hemiacetal. You can see this carbon here does have a hydrogen. It has an R group, it has an OH group, and it has an OR group. So therefore, this will be a reducing sugar. For the next one, we have galactose with glucose. We can tell this is galactose because this carbon 4 here has this hydroxy group up instead of down. So galactose is a C4 epimer of glucose. And we can see that we have our CH2OH group up, and our linkage to the oxygen here is also going up. Therefore, this will be a beta linkage, and this is carbon 1, and this is carbon 4. We also have the same motif of the hemiacetal, COCOH, right here. To help you see the hemiacetal better, remember this ring is going to be opening and closing. And when this ring opens, this is going to become an OH. This bond will break. And then on this side, you form the aldehyde. And so the hemiacetal contains the hidden aldehyde, which is the reactive site and why it is a reducing sugar. For the last one, you can see here we have glucose. Again, the 1 carbon. And we have the bond going opposite of the C2OH. This bond is going down. However, when we look at this molecule, this is going to be fructose. Furthermore, you can see that this fructose is actually inverted. This is carbon 1, 2, 3, 4, 5, and 6. This is the anomeric carbon here. This linkage is going to be alpha 1, 2. To determine if this is a reducing sugar, we have to look for the hemiacetal. However, with fructose and glucose, there will not be a hemiacetal or hemiketal present. If we check this carbon, we have a hydrogen, we have an R group, we have another R group, and then we have an OR group. That does not fit the hemiacetal, so this will be a non-reducing sugar. Now we are looking at polysaccharides, and we have to determine the type of glycosidic linkage and what the simplest unit is. For the first one, you can see that this is a polysaccharide made of glucose, and you can see that it is going to be alpha, and it is between carbons 1 and 4. For the next one, if we look here, this is the same exact linkage going on as up here. We now have a second branch going on. If we look at these two units here, this is on carbon 1, and if we look at this linkage here is carbon 6. This is going to be an alpha linkage. So for this polysaccharide, we have alpha 1,4 and alpha 1,6. The unit will also be glucose. For the last one, you can see we have 3 glucose molecules. And if we look here, this is going to be beta, because this will be up on the same side as this. And this will be between carbons 1 and carbon 4. The first polysaccharide is amylose. The second one is amylopectin. Both of these make up starch. And the last one is cellulose. What is interesting about these three is that our bodies can break alpha 1,4 linkages. We can digest starch. However, with cellulose, we cannot break up these glucose molecules because we don't have enzymes that can break the beta 1,4 linkages. That concludes the video on common saccharides.